Hi folks, Ken Ring of www.predictweather.com. We've been told that the Russian heat wave in recent weeks and the Pakistan floods have come about because of recent unusual jet stream formations. Well, I think this is a subtle ploy to get the public wondering if the weather has finally gone nuts to do with global warming and climate change. Well, don't fall for it. The jet stream is always there and it's never unusual. And I'm just going to talk to you about jet streams. I'm going to do it in two parts because otherwise you'll get bored and fall asleep, and or if you don't, I will. Now these things called jet streams are nothing but normal waves of air wandering around the Earth at very high altitude. And they move from west to east, they also move from north to south. They're actually air mass dividers, and they come about as the result of cooler air on the move. When you look at a weather map, you can see areas of high pressure and areas of low pressure. There's a big H and there's an L, and between them there are these tighter lines called isobar lines, and that is the so-called jet stream. And as long as there's an atmosphere, there's going to be tighter isobaric lines somewhere, and there will be these jet streams. The jet stream itself is actually on a higher level than the rest of it. The air is always moving, it's always moving fast in places, and it pushes that faster air up above it. And always in the rivers of the air, there's different speeds going on, just as there are more powerful currents in the sea. So the term jet stream is just a buzzword. You know, we could just as easily call something in the sea jet waves, but it wouldn't mean much unless you're a fish. We do live, in effect, between two giant oceans, and the first is known as the sea, and the second is known as the atmosphere. And we're between the two. Now, one is wet all the time, and the other is wet some of the time. Any wind originates with movement in either the sea surface, where the air joins to the sea, or high in the air, where these jet stream things form. And they modify each other, these two sources of wind, in the middle altitudes of the air. Now, in the sea surface, the air is joined to the sea over 75% of the whole of the surface of the planet. And as the air moves, as the surface currents move, the air moves along with it, and it creates pressure differences above the sea surface, such that where the air is higher pressure always flows to lower pressure. And so the region that it's entering assumes lower pressure. And if this were not so, then movement couldn't be possible. It would be two equal opposing forces on something moving, and the movement would cease. Now, in the air, the same wave dynamics apply. Just as the moon moves the sea, it also moves the sea of air. The moon moves the actual sea, the water sea, along because the moon changes hemispheres as part of a 27-day cycle. We've talked about this before. If that's the Earth, well, it's actually on a tilt, and the moon going around it changes hemispheres. So one time it's over the northern hemisphere, 2 weeks later it's over the southern hemisphere, because the Earth is on a tilt. And it's 23 degrees, and that shifts huge volumes of water around that end up becoming the tides. And in this cycle, the moon alternately drags heat in both wind and both water and air from the equator towards the poles. And with the air, it's much easier to do this because the air is lighter, and it changes every 13 days, changes direction with the air, but the air is 800 times lighter than water, so it can move that much faster. The water only moves slowly, and it takes a season for the temperatures of the water to heat up or cool down. There's also a vertical up and down lunar displacement due to the moon's gravitational force, and that depends on how close the moon is to the Earth. And when the moon is closest to the Earth, that force is the greatest, and that's called the perigee, and that causes the king tide down at the beach, which is the highest tide of the month. So that movement is going on as well. Well, I'll tell you about what forms the jet stream in terms of the moon in the next blog, because we've kind of come to the end of our allotted time for this one. So please tune in to the next one. I'll see you then.